of it picked a 10-year period, a very recent 10-year period, and found that he was averaging more than 4 publications a year. And in that 10-year period, there were 4 years where he published 5 articles, 1 year where he published 6, and 1 year where he published 7, which is virtually unbelievable. He is responsible for a great deal of grant funding. Since he has been at the University of Tennessee, it has amounted to more than $500,000. We are so grateful that he is with us today. And David Anderson is speaking on climate change and human culture, saving the past and present for the future.
Well, thank you very much for that wonderful opening, Mark. And I really appreciate the invitation to be here. Today, we're going to explore 2 big questions. How does climate change threaten cultural heritage? And how do we respond? And I've got a lot of slides, but the talk is being recorded. If you want to go back later and look at the details, I have references for all the slides. And I'm happy to communicate with you. My email was on the title slide, so feel free to ask me any and all questions you would like in the chat or down the line. The inspiration for this talk was the anthropology department's visiting lecture series in the fall of 2020, now virtual lecture series, which was on climate change and human response. We had 32 talks from people all over the world examining how climate change related to things like archaeology and architecture, human cultures and languages, human health, disaster management, information management, curation, forensic studies for disaster victim identification, and combating climate denialism. Now, in archaeology, anthropology, there's been great and growing interest in climate change in recent years. One of the things I did just for fun was look at the abstracts for all of our national meetings conferences for the last 30 years, the Society for American Archaeology, and looked at how many papers had terms like climate or climactic or climate change, climactic change. And you can see that the numbers have gone up, particularly in the last decade. And in fact, it's just in the last decade that we've started using the term Anthropocene readily very often. There are good sources that you can get online to learn about climate change. I'm going to talk a little bit about what's happening and how it affects heritage, cultural resources, human cultures. But if you want to get just incredibly wonderful and detailed reports, just search IPCC or National Climate Assessment. And they also have summaries for policymakers. So there are typically 2 versions of each report, a very long and detailed version with lots of good science, and then a shorter summary for policymakers. IPCC stands for Intergovernmental Panel on Climate Change. There have been 5 assessments so far. A 6th is due out in about 2023. And for the first time, cultural resources are going to be a part of that. It's been a minor part in previous reports. That's an intergovernmental panel. The United States government, however, has also been tracking climate impacts. And the 4th National Climate Assessment came out about 2 years ago. So these are reports readily available. So what is going on in the Earth system? I think we all know that basically temperature correlates closely with carbon dioxide, greenhouse gases in the atmosphere. This is 800,000 year records from Antarctic ice cores. The top is CO2. The long-term average is between 200 and 300 parts per million. And then the temperature is the bottom chart, which goes between roughly 5 degrees above the average to 10 degrees below when it gets colder. Now, when you combine these curves, they're almost in perfect agreement. And you can see then that when greenhouse gases, particularly CO2, is in the atmosphere, the more, the warmer, the less, the colder. That's really unarguable. The science is just unquestionable, and we've got an over 500,000-year record. Now, atmospheric CO2 is increasing and will continue to do so for some time. This is a very famous Mauna Loa Observatory recording of parts per million of carbon dioxide in the atmosphere. Remember, the long-term average is 200 to 300 between glacial and interglacial cycles. As of December 2020, the latest reading, we are at 414 parts per million. We're way above the 800,000 year record. And that's going to continue for some time to come. Now, there are a number of scenarios as to how the future is going to play out. They're called emission scenarios, and they're technical term representative concentration pathway. Basically, they're scenarios predicting essentially possible amounts of emissions that will occur from low, where we basically stop greenhouse gases essentially immediately. That's the RCP 2.6. To we just continue as we are, which is the 8.5 at the top. Now, these have direct implications for global temperature. These are these pathways showing the temperature changes that will result. And there's a lot of lines because there's a lot of different futures depending on what we do. And you can see that the worst case global temperature this century will go up 3.2 to 5.4 degrees centigrade in the upper right. The lower right, you can see that if we stop emissions right now, temperatures are still going to go up to perhaps as much as 2.3 degrees. So we're sort of on a path that hopefully we can try to minimize the long-term effects. Well, I'm going to talk about a number of slow onset climate and related changes and how they link to cultural heritage. I'll talk about each of these: sea level rise, permafrost melting, changes in precipitation and temperature, changes in biota, ocean acidification, changes in health and mortality, and migration inland into healthier areas. Now, these are slow onset, but sudden changes in these variables are what is known as extreme weather events, and I'll come back to those because they're important as well. Starting with sea level rise, there are a number of scenarios for this century with a low rise of perhaps a third to half a meter to the probable rise of about a meter. But then if we don't halt or reduce greenhouse gas emissions, the rise this century could be 2.5 meters or about 8 feet. So there are a number of different scenarios. Now, my own research with a number of my colleagues has looked at sea level rise and how it will impact archaeological sites as well as human populations in areas to be flooded. This was published in PLOS One in 2017, and we looked at basically sites in coastal areas, looked at their elevation. The paper was widely reported in a whole host of media outlets, and that was pretty exciting. I think I spent 2 weeks talking with reporters, and the model has been since emulated by a number of other scholars in a number of parts of the planet. Well, with regard to sea level rise, this is a meme that I think most people will relate to. How many sites will be lost moving forward into the future? And these are just different captains of the Enterprise or in the upper right, Voyager. And the bottom line, though, is that just this century alone, we're going to lose at least 20,000 archaeological sites in the Southeast, just in the 8 states in the study. Going further out 2-3 centuries, the numbers go up pretty dramatically. Now, similar chart, these are for sites that are already deemed significant on the National Register of Historic Places. These are pretty important archaeological and architectural sites. And again, this century alone, we're going to lose over 1,000 of these, or they'll be severely impacted by sea level rise. And then moving forward, the numbers go up and up. Now, that model that I did with my colleagues is called a bathtub model. If sea level goes up a meter, how many sites are lost, how much land area is covered. It's now been emulated by a number of scholars. The World Heritage Sites were looked at a year later, and I've reviewed papers where this is being done in a number of other parts of the world. So it was a study that a lot of people are doing similar things with. Now, there are other ways that sea level rise is being examined, explored. If you like lighthouses, there's a Lighthouse Digest magazine that has a threatened lighthouse doomsday list. and they have 56 lighthouses listed on it just in the United States. You can see at the top center, that's Body Island. I did archaeology there about 30 years ago, and that's a picture of the excavations from the top of the lighthouse. Now, this doomsday list, from my experience, is probably underrepresenting things because Body Island was 10 feet above sea level, and I think it is likely threatened. So there are probably more lighthouses alone threatened. Now, with regard to sea level rise and storm surge, erosion of the barrier islands, the Cape Hatteras Light is perhaps the most famous study of relocation that has taken place. It weighed 4,800 tons, and it was moved almost 3,000 feet inland at a cost of about $20 million. So we know we can move resources inland if we need to. Another example of a very famous locality that is in need of protection is the Kennedy Space Center. It's at about 10 feet, and in fact, there are buffers being built on the seaward side to prevent storm surges, things like that. And interestingly enough, a Saturn V weighs a little bit less than the Cape Hatteras Light. So 50 years ago, we knew how to move lighthouse-shaped objects, and we can do it again if we need to. Now, it isn't just lighthouses. The Union of Concerned Scientists has done a study of residential and commercial properties, and by the end of the century, as many as 2.4 million of today's residential properties and over 100,000 commercial properties are at risk from commercial flooding due to rising seas. So many of these are likely to be, are unquestionably historic, and there are people living in most of them or working in them. So that's a challenge as well. Now, sea level rise is not just this century or the next century. What we've put into the atmosphere is going to have long-term trends, long-term changes going forward. And there have been studies showing changes as far out as 10,000 years. And basically sea level, if greenhouse gases aren't reduced, will keep going up to the point where large areas of, say, the southeastern coastal plain will be flooded. It's significant and important what we are doing. Archaeology offers a time depth in terms of what happened in the past. Sea level came up 300 feet at the end of the Pleistocene, and people moved inland. We're going to see, hopefully not that level of increase in the future, but archaeology gives us guides as to how people responded. And there are studies now of projected sea level change 12,000, 10,000 years into the future. Now, another area that's affected, this is a global challenge, a broad challenge. The permafrost is threatened melting. And we all know that the Arctic ice cap is melting. In fact, in the summer, the Arctic is navigable. It wasn't. Edmondson took 2 years to cross it in about 1906 to 1908, the first crossing of the so-called Northwest Passage by sea. We're likely to have open water completely if we don't stop greenhouse gas emissions by the end of the century. That's the RCP 8.5 solution, and at least seasonal ice, only seasonal ice moving forward under current scenarios. So how does that affect frozen areas on the land nearby? Well, these are vast areas, over 22 million square kilometers in the Northern Hemisphere. Is characterized by permafrost. That's basically ground frozen below the surface, that when it warms, it melts, it releases greenhouse gases. And from an archaeological perspective, it causes the artifacts, the cultural remains found within them, or they begin to deteriorate. So we're talking about a huge area, 6 to 8 million square kilometers will be affected. Now, here are examples of the things that are found. We have extinct species, dogs, very fragile artifacts, tombs, Scythian tombs, for example. That's a tomb on the lower right, with remarkable preservation. But once they begin to thaw, the remains deteriorate. So here's another example from the Arctic of the remarkable preservation. You see the comber fork, you see the masks. These are the things that once they're exposed and thawed, They are very fragile and will deteriorate quickly. So the melting of the permafrost, not just sea level rise, is going to require tremendous investments in recovery, conservation, and curation. Moving on, precipitation and temperature. We know dramatic changes are going to occur by 2100. And these, in combination with several variables I'll talk about, will affect where people live, where they grow crops, and so on. There'll be changes in biota that are dramatic, and this is just a map showing projected changes from 1990 to the end of the 21st century, our current century. And basically, you just see from the top and bottom map, there are going to be dramatic changes in biota that are occurring. And these vary depending on emission pathway scenarios, but still very dramatic. Now, just as an example of one change, the taiga steppe boundary, basically where the trees stop in that upper left graphic showing Canada, that's where the trees are. And the tree line where they stop and the taiga begins. When we have warmer climates, the tree line is much further north. And in the mid-Holocene, it was about 500 kilometers north of where it is now, but it's moving north rapidly. Here in these Blue Ridge, we're seeing effects of altitudinal change. Basically, tree species that are adapted to cooler climatic conditions have to move upwards, and eventually they run out of mountains. So there are problems with that as well moving forward. Ocean acidification. Basically, as CO2 in the ocean increases, and the ocean is a dramatic sink for CO2. It's sort of a place where a lot of it is stored. But as more and more is stored in the ocean, the pH drops, that's the blue line, and acidification increases. And acidification of the ocean not only affects archaeological resources, deteriorates things like shipwrecks and so on, but also marine biota are affected by it. So it's another area that we need to consider in addition to the archaeology. Changes in health and mortality are affected by all of these. A recent paper came out talking about a shift in the ideal human temperature niche. Basically, it's arguing that there are going to be places on the planet that are no longer ideal for human settlement, and that people will have a hard time getting by and may have to move out of these areas by the end of the century. The example from the United States that was shown is here. I'll flick back and forth. This is where we are now. The ideal niche includes the Southeast, and of course, Tennessee is a great part of that. And then that's what happens at the end of the century if we don't stop, under the extreme emissions scenario. So you can see there's a pretty dramatic shift in the ideal environment for people. This will affect not only people living, surviving extreme temperatures, but also crops and so on. Now, in terms of changes in health and mortality, from all over the world, there have been studies of predicted excess mortality, basically related to heat. That's the red. The curves all go up this century. The good side, perhaps, is that we have fewer cold-related mortality. That's the blue. You see that there are declines across much of the planet. But nonetheless, there are concerns to people. Now, in the near term, we've talked about relatively slow-moving climate change. In the near term, there'll be more extreme weather events. And this is a definition from the IPCC. An extreme weather event is simply an event that is rare at a particular place and time of year. And that varies situationally, rare in one area, maybe not so in the other, but that's at least what we're referring to. And this is a chart since 1960 of extreme weather events. And you can see that it's going upward. This runs through 2015, and it's been going upward. And we know classic examples of extreme weather events. We're living through them: wildfires in California, for example, hurricanes like Sandy, that basically affect where people live and archaeological and historic resources. So slow onset climate change coupled with increasing extreme weather events will lead to mass movements of people in the years to come. There's no doubt people are going to have to move to basically healthier and safer places. We need to be thinking about the numbers of people who will move. And then how will we deal with cultural resources? How will this migration affect cultural resources, the human cultures, the archaeological sites, historic structures, and so on? A term that's become popular just in the last year or so is called managed retreat. And this is a complex chart, but basically it's showing that in virtually every country in the world, a substantial portion of the population, at least that is on a coastal area, is going to need to move inland or to coastal or to cooler areas. So managed retreat is a term that's in place. If you wonder if we have options to this, protection in place, staying in place, unless we develop floating cities perhaps, is not an option. There have been studies of the cost of building seawalls, barriers. The lower right is a fictitious example of perhaps 200 years from now, a city with a 200-foot seawall. The costs of these are trillions of dollars, and the building of them damages large numbers of structures, sites in countryside where people are living. So the same study that my colleagues and I looked at sea level rise, we also looked at the numbers of people just in the southeast that will have to move inland, and a minimum of 3 million are going to have to move this century with basically a 1 meter rise in sea level. That's just in the southeast. And with a 5 meter rise, the numbers go up pretty substantially to in the neighborhood of 10 million or more. So population relocation will lead to a loss of cultural resources in the areas people leave and where they relocate. We have to plan for them, build for them, and so on. And these resources include structures, landscapes, sacred areas, cemeteries, human communities, and archaeological sites. So how do we address the loss of cultural resources moving forward? Well, one thing we need to do is we need to refine our models continually. Now, the model that my colleagues and I did in 2017 has already been evaluated, critiqued, and improved on, looking at things like rainfall and storm surge. So there are wonderful studies moving forward. The field is changing very rapidly. This is showing flooding in the Hurricane Harvey area near Houston. We need to involve many more people, many more parties. We're all involved in this, or stakeholders. This is a shell ring on an island in South Carolina, the South Carolina coast. Over half of it has been lost in the last 5 years. So a major effort to recover information between state and federal agencies, the National Park Service, and state agencies has been underway to recover information before it's gone forever. Now, these impacts aren't just related to coastal areas. Excess rainfall, flooding can cause the slumping we see here along the Tennessee River. And I've had direct involvement with this. This is a picture of a bluff face along the Tennessee River at the Shiloh National Military Park. On the right, that yellow line is pointing to the base of a 20-foot high First Peoples Native Americans Indian mound that was literally eroding into the Tennessee River. An attempt at riprap on the lower left did not stop the erosion. In fact, that's a recent erosion shown right on it. So the Park Service and I with colleagues spent 5 field seasons and 4,000 person days conducting excavations, recovering information that would be lost. Just showing the scale of the kinds of challenges we'll be facing in the excavation analysis and so on. So these are pictures of that field work. There's a monograph available in PDF format, free online. You can come back and get that if you would like. And just as an example, this is one site out of many that will be threatened. A vast amount of information, lots of artifacts, notes, photographs, and so on was collected during this field work. Now, there are wonderful things that we learn as a result of these projects, unanticipated consequences. For example, we learn a lot of new things about the human past. When we were digging this mound, we noted, you see the yellow line, that there was a thin layer over that gray deposit. That's actually a mound stage. And we peeled it back on the lower right. You see it was covered with a red soil, red actually deposit. So the way we've portrayed these mounds for over 150 years as grass covered was probably not correct, at least in some cases. So we learned new and wonderful things. Another thing we've learned from studying coastal shell middens and shell rings that are threatened, this was a piece of copper that was found on a Georgia shell ring that came from the upper Great Lakes, copper mines up in that area. So it doubled the area that we knew these objects were circulating in. So we are learning new things as a result of this. Now, in terms of determining what will be lost and deciding what will be saved, that's a major challenge for us. How do we do this? We have to develop a wide range of approaches. We need to collaborate and participate. We need collaboration and participation by a large number of parties. We need to consider a wide range of resources and approaches. We need to design appropriate fieldwork and analysis efforts. And we need to make sure that what is saved is maintained for the long term. And finally, the results of this should be made public and used to guide subsequent stages. So collaboration and participation by all impacted parties, not just archaeologists or architectural historians. This means communities, descendant populations, and so on. And there are tremendous benefits and perspectives to be gained by that. As an example, collaboration means involving all stakeholders. These are areas of America's first peoples, their territories or ranges. We need to consider a wide array of cultural and research concerns, consider multiple perspectives and voices. And one example of this, I talked about World Heritage Sites a bit ago, showing how in the Mediterranean they were threatened by sea level rise. What's interesting is that what we think of as significant is related to our cultural preconceptions. And most World Heritage Sites are state level monuments, hierarchical societies very much like our own. And very few of them, except for the line in the middle, which is Jamaica, are what we would call more egalitarian or societies. So we have to be open to a range of perspectives. Now, we need planning. For reservoirs in the past, I'll talk about one that I spent a number of years working in about 40 years ago. There were major mitigation plans. This is 3 volumes, about 1,000 pages on how we're going to rescue, recover materials to be lost by just one reservoir, the Richard B. Russell Reservoir on the upper Savannah River. This is showing where it is, a little south of where we are now. And basically, it examined 210 square kilometers. That was the flood pool, and 732 sites were found during a survey, 1 per 71 acres. And then a lot of work was done. Now, this project cost $5 million in 1980. There were nearly 3 dozen large historic and pre-contact sites that were excavated. I wound up directing excavations at 8 of them with a team of people. This is one of the sites, just showing an example. It's about 4,000 years old, just giving you an idea of the scale of these endeavors. The black stains in the lower left are pit features, and then a reconstructed poster of what life was like. Another site, a deeply buried midden, that dark band highlighted by the green arrow, was another occupation about 4,500 years old. Using heavy equipment, we removed the overburden, the fill above it, and then conducted a block unit excavation. And that in the upper right, you see there are shoals in the river. We think this was probably a fishing camp for the local peoples at the time. Another site was a large village. That area at the top, it started out as a plowed field. It was, when first found, there were about a half a dozen artifacts found. As more and more work was done, tremendous things were found. That area is about the size of an aircraft carrier, just to give you some idea of the large area stripping. The circles are controlled surface collections and then block units. And then this turned out below the surface, below the plow zone, to be a late pre-contact village that was first unfortified, and then lightly fortified, and then more strongly fortified, and then was abandoned. Here's an example of a reconstruction, a painting, and then showing the scale of the field project, just to give you again an idea of what these projects can entail. Here are pictures showing the fortification ditches and then the faint post holes from the palisade line in the lower right. These are the kinds of things that you can find when you open large areas. Now, the reservoir project was unusual in that they considered a wide range of materials, historical sites, Revolutionary War forts, farmsteads. Industrial archaeology occurred at a number of mill sites. Oral history also occurred of populations that might not ordinarily be considered, instead of just the plantations of the rich and powerful. The people that lived and worked there were also considered. That was very unusual for the project at the time, although now that's much more commonplace. Architectural documentation of many structures occurred. The Historic American Buildings and Engineering Structures projects worked and documented many structures. And some of them were relocated, not just the Cape Hatteras Light. In this case, some bridges and 2 farmsteads were removed. So these are things to consider when you're flooding areas, when areas are threatened. An unanticipated consequence was, over the course of the project, we began to realize that the abandonment was not just local, that by over about 200 years, much of the Savannah River Valley was depopulated. There were probably some people there, but most of them moved elsewhere. And it's looking like, this was my dissertation research, looking at tree ring reconstructed rainfall. It looks like climate change, decreased rainfall affecting crop yields played a role in the abandonment that took place. So that was something we just knew the site was abandoned. About the Rutgers Bottom site was abandoned around 1450. We weren't sure why, but it led to considerations that are still being explored decades later. So we also need a national, indeed global level of effort in information management and planning. We need to link cultural data at progressively larger scales and involving all groups. These are 2 projects, Coalition for Archaeological Synthesis and DINA, the Digital Index of North American Archaeology. I've been involved in 2 large database projects, PIDBA, compiling Paleo-Indian, late Pleistocene site and artifacts across North America, and then DINA, archaeological site data. We have over 1 million sites from large parts of the United States to plot where people were in the past, how climate change affected them, and so on. So developing these kind of data platforms is essential. We can't just plan for climate change effects in small areas or even individual states and perhaps even countries. We need to think about this at a very large scale. On the right, that's 500,000 sites from Eastern United States. We need to design appropriate field methods, site discovery methods, analysis and reporting efforts. Examples of these include things like LIDAR, remotely sensed elevation data. These are shell rings along the South Carolina coast that basically they show up through this remote sensing, but it also helps us find things like rice dikes, roads, earthworks, and so on. So that's a technique that is increasingly automated and useful. We need to work with geologists and geoarchaeologists to determine areas that are threatened with, well, where sites are likely to be located and where they're threatened with loss. This is work in the Mississippi Delta a colleague is doing. Back at Shiloh, 2 of my anthropology department colleagues, Amy Mundorf and Katie Cochran, were looking at LIDAR to look for mass burials. And I said, well, I dug an Indian mound near there. You might want to check it out. So they did overflights of that. And remarkable documentation of features on the Indian mound group. You can see a palisade line very faintly that's barely visible on the ground. So this is a technique for finding features that can be used anywhere and is increasingly so. It can also show the extent of erosion. These were the transects over the main mound that my team and I excavated, and they show in the bottom, they show the extent of erosion. So these techniques can not only find sites, they can show how threatened they are. Remote sensing is something that we are doing more and more of. This is the Etowah site near Cartersville, Georgia. Basically, those are structures around a plaza. Why dig or direct your excavations to important areas found by remote sensing? Now, we have to make sure that what we recover is saved, maintained for the long term in secure facilities. That means don't store things in coastal areas. They should be well into the interior. This is called the curation challenge that we face. And these materials should not only be protected, but they should be accessible and used by students, by researchers, and displayed for the public. You've all seen this movie, perhaps. This is not what should happen to materials. They shouldn't be boxed away. They should be saved and made available to everyone. So the results of all of our work at every stage should be publicly reported, widely shared, and used to guide the subsequent stages of investigation. Turning back to the Russell Reservoir work on the Upper Savannah, there was a technical synthesis that was produced of all the investigations that I and a colleague produced a few years after the end of the excavations. There were also popular overviews produced. This is of the first peoples that took place in the reservoir, and then there was a popular volume of African American life on the Upper Savannah River in the area. So these are important. Literally thousands of copies of these were produced and were distributed to schools. Now, to wrap this up, in the last 5 or 10 minutes, I'm going to come up with some examples of studies that I've been doing as to how do we estimate what is threatened, how many sites are threatened with sea level rise. You saw the study earlier that we did. We know that there are going to be nearly 50,000 square kilometers lost in the Southeast this century alone, assuming we have a 1 meter rise in sea level. So that's a large area. Well, from existing site information in the areas highlighted in red are military bases or national forests where there's been a lot of work. The survey intensity on this map is shaped, except in Ohio where we got county level data, it's shaped by where a lot of work has happened. And that's typically federal installations where they can afford to conduct the work. So almost every blotch on this map in the Southeast is a military base or a national forest or so on. Well, you can look at the incidence of sites in areas that have been intensively examined. And that gives you an idea of how many sites are out there. And in intensively examined areas, we typically find about 1 site per 110 acres. So we would expect in 50,000 square kilometers, a lot of archaeological sites. This is one way you can begin to estimate how many sites are out there. Now, most areas are not surveyed at the level of these federal installations, so there's a lot of sites that are out there that we're missing. If you look at the numbers of sites in our DINA data set, the analysis we did, with a 1 meter rise, the average numbers of known sites are about 1 site per 628 acres, and the numbers go up. Basically, the numbers of sites in the Southeast this study shows is probably at least a minimum of 6 to 7 times the numbers currently recorded. So if we did the level of effort on federal installations across the region, would have 6 or 7 times as many sites, and realistically probably a lot more, because the actual number, what we think of as an archaeological site changes. We also have to consider buildings, landscapes, cemeteries, a whole host of things. And our ideas of what we should look for are changing all the time. We must be continually reassessing our predictive models. This is a model on a forest in South Carolina, National Forest, Francis Marion, produced by an MA student here at UT for his thesis. And we need to be refining these. This is a wonderful model for finding First People sites, but it's not as useful for finding sites by historic populations, colonists, and so on. So we've talked about numbers. Now, the real question, how much is this going to cost? And you see the line from the movie and book, The Right Stuff, with no bucks, there's no Buck Rogers. It's important that we begin to get a handle on what this is going to cost. Now, to survey areas, the Department of Defense and other agencies have done detailed studies of what it will cost to do this. And a very rough ballpark is between $100 and $1,000 an acre to intensively survey, and not only survey, but analyze, write up, and then curate the materials. So you can use those numbers and the numbers of acres that are threatened by sea level rise in the region, 12 million acres with a 1 meter rise. Given a 1 meter rise, costs at $100 an acre are 1.2 billion. At $1,000 an acre, they're 12.2 billion. If sea level goes up 5 meters, the numbers go up, as you can see, quite a bit. Now, this seems like a lot of money, but we're talking about a $2 trillion stimulus package right now, and our federal budget in any given year is somewhere between $2 and $4 billion. So this could be amortized over the next 40 years and would not be all that unrealistic to consider. So that's for survey. What about actually doing mitigation, excavation, architectural documentation, oral history? Well, we're turning back to the Russell Reservoir project. That cost $5 million in 1980, and that's about 16 million in today's dollars. So that was 215 square kilometers. The area threatened, 50,000 square kilometers. That's 250 of these reservoir projects in the Southeast alone this century. That's the area that's threatened and the scale of the challenge. So if it cost 15 to 16 million to survey one reservoir in 1980 dollars, and we have 250 of them, we're looking at potentially $4 billion for mitigation of the area that is currently threatened in the Southeast alone. Now, people have been living in coastal areas for the last 6,000 years. Sea level has not fluctuated more than a meter or two in that time. So we have a much vaster archaeological record there than we do in many other parts of the country, and particularly a little further inland. So I really believe that the actual cost is several times greater than it would be for an inland reservoir. So I just picked 3, you could pick 5, but we're looking at between, roughly $12 billion for coastal mitigation if we do it according to the model from that reservoir study. And of course, we're much more sophisticated now. So that's what we're looking at moving forward. And again, this is not all at once, this is over many years. So to conclude this, global climate change poses tremendous challenges for our civilization and for archaeologists. However, we've faced these challenges before. There have been more than 8,000 major dam projects in the United States that have been conducted over the last century, and many of them have had archaeological investigations. Perhaps most famous of these are the TVA, or at least best known to us at least, are the major TVA dam and lake projects in the Southeast, many of which had major archaeological investigations with materials reported on and curated by people here at the University of Tennessee. So to conclude this, I think this is one of the greatest challenges that our civilization faces, and we need to be considering the effect on our culture, our history, and so on. And all of us should be invested in this effort. So thank you for your time. And if anyone has any questions, I'll be happy to go. And sorry if I went a little on that. Thank you.
You're very grateful to you, Dr. Anderson, and we're sorry that people